All right, here we go, 6-3A, and then we'll finish up 6-3 when we come back the next time. All right, today we're going to do binomial. Do you know what a binomial is? How many terms does a binomial have? 2. Good. You remember that from last semester. I could say last year, and that would work. All right, binomial radical expressions. Do you know the difference between an expression and an equation? No? Yeah, an expression is something that just sits there. This is an expression, 2x plus 3. Can I really do anything with it? Not really. Then if I write 2x plus 3 equals 7, that's an equation. Okay? So we're going to deal with expressions. We're not dealing with equations. We're not solving for anything. So here we go. We got 2 parts today. Part A. We're going to add and subtract. Oh, that sounds fun and easy. It's not too bad. All right, we're going to add and subtract. Now, when you add and subtract radicals, they have to have 2 things in common. They have to have the same index. Do you remember what the index was? That's the little number on the outside. Okay? They have to have the same index. That's this. And they also have to have the same radicand. I love that word. The same radicand. And a radicand is the stuff on the inside. So they have to be like terms. You know how like you can only add x's with x's and y's with y's? It's the same thing for radicals. They have to have the same index and the same radicand. So here we go. Let's do a couple easy ones. Here we go. You ready? Number 1. Let's take 5 rad 3 plus 2 rad 3. Now, it's just as easy as you think it is. 5 rad 3 plus 2 rad 3. How many rad 3s do I have total? 7 of them. Exactly. And this would be 7 rad 3. Yay! Isn't that fun? It's good, clean fun. All right, here we go. We'll go 7 4th root of 5 minus 3 4th root of 5. I mean, it's exactly like you think it's going to be. There's no tricks here. Okay? So I have 7 of these rad 4 of 5s, and I have minus 3 of them. I end up with 4 4th roots of 5. All right, so you're sitting there thinking, wow, she is just insulting my intelligence, isn't she? All right, or you're enjoying it. Like, yeah, this is easy. I can do this. All right, 2 rad xy plus 12 rad xy. Okay, so can we combine those? Sure. Yeah. They have the same radical. They're both square roots. And they have the same radicand, which is xy. And so how many rad xy's do we have? We have 14 of them. There you go. Okay, so here we go. How about 2 cube root of x plus 5 square root of x? Can I simplify that? No. You can't simplify that at all. Their radicands are the same, but their radicals are not. Their index is not. This is a cube root, that's a square root. You cannot combine. So you could say cannot combine. You wouldn't say no solution because it's not an equation. Cannot, combine. So it's as simplified as it gets. That's the answer to it. All right, so that's pretty basic, pretty easy. Now let's go on to part B. Now I'm going to give you some that look like they can't be combined, but they actually can. So we need to simplify and combine. We need to simplify our radicals first so that we can see if they're the same radicand, and then we can add them up. So here we go. Number 2. I'll call this letter A. I should have called those ABCs, whatever. All right, number 2, letter A. 5 rad 20 plus 3 rad 45. Okay. All right, so people will get to this problem and they'll say, oh, because, of the last section, I can't combine those. They don't have the same radicand. But are they completely simplified? No, neither one of them is. both of them can now be rationalized. Rationalized means you take any perfect squares out of there. So is there a perfect square in 20? Yeah. 4 times 5. Perfect. Is that what you said? Sure. We'll go with that. 4 times 5. All right. So take the square root of 4. We get 2. And what do we do to that number on the outside? Multiply. Good. And so 5 rad 20 is the same thing as 10 rad 5. Have you ever tried that? Have you ever wondered, are they actually the same? Have you ever gone to your calculator and you go 5 rad 20 and 10 rad 5? Oh, let's see. They are the same. They're just simplified. It's kind of like saying like 5/10 is the same thing as 1/2. Just simplified. Okay, and then over here, is there a perfect square in 45? Sure. How about 9 times 5? Square root of 9 is 3. I bring it out and multiply. And so now, once I have simplified, now I look at it and I go, oh, they were like terms, weren't they? So we can add these up. And so if I have 10 rad 5s plus 9 rad 5s, I end up with 19 rad 5s. All right, what's that? You want to try one? Okay. Yeah. All right, here we go. You try this one. How about 6 rad 18 plus 4 rad 8 minus 3 rad 72. Okay, I'm going to let you try this one. Okay, is there a perfect square in 18? Sure. How about 9 times 2? And so you take the square root of 9, and you get 3, and multiply it times the 6 on the outside. So that simplifies as 18 rad 2. Make sure you simplify all of them, okay? 8 is 4 times 2. And you take the square root of 4, which is 2, and you multiply that on the outside. So that's 8 rad 2. And then finally, there are a couple of perfect squares in 72, but you need the biggest one, which is what? 36. 36 times 2. And so then we take the square root of 36 is 6 times 3, and I get 18 rad 2. Now, do you ever look at this and you go, oh, there's an 18 on the end and a negative 18 on the, or yeah, other way. And then you can just cancel those out, and so your answer is 8 rad 2. Yay, who got that before I did? Oh, good, quite a few of you. Nice job. All right, so let's do this one, number 3. So those all had numbers in it. Let's do one with variables, okay? Let's say that I have 2 cube root of 16 x to the 3rd plus 5 cube root of 54 x cubed. All right, so now we have to simplify a little bit more, but you should be getting used to this. We did a lot of this, you know, on the block yesterday. So here we go. Now, this is cubes, perfect cubes. I know 16 is a perfect square, but we don't care. Who cares it's a perfect square? We are looking at perfect cubes. Are there any perfect cubes in 16? Do you know your perfect cubes a little bit? 8. Good. How about 8 times 2? So the cube root of 8 is 2. We bring that outside and make that a 4. And we leave this 2 alone. And then 3 goes into this little 3 right here exactly 1 time. All right, let's simplify this one over here. Are there any perfect cubes in 54? 27. You're going to get used to these. They show up a lot. 27 times 2. So then take the cube root of 27, which is 3, multiply by 5 on the outside, leave the 2 behind, and then 3 goes into this little baby 3 right here 1 time. And check it out. Now, if they're not like terms, then you just leave it, and that would be your answer. There's nothing to combine. There's nothing to add. You might get some of those in your homework where you do them, and then they don't combine. That's okay. They don't all have to. All right, so now let's add them up. 4x cube root 2s plus 15x cube root 2s gives me how many total? 19x cube root 2s. Perfect. Done.